Hi, welcome back to the breadboard. I've been busy creating a home automation set of switches for my wife's sewing room. Originally I put up some off-the-shelf remote control switches, but they don't provide easy remote access. So I've been using some of these, which are the Martin Jerry, works with Amazon Alexa MJ-S01s. I got a few of them from Amazon.ca, and I've got 3 of them already put in here. And I thought what I would do is I'm going to show you how I'm programming these. Right now, in the early part of 2022, it's become really easy to be able to program them. So I thought I'd take a break out of assembling this. I will do a separate video on how I designed the box for this and everything else. It's 3 of the switches in. This is where the last one's going to go. And this is going to go up in the sewing room. So this is a 3D model I have of the sewing room. It's just the walls of the outside of the sewing room. You can see it's on a bit of a leaning roof. And inside I built these beams across the sewing room. Make it a bit bigger for you. And underneath are suspended lights this way and this way. And also over here is what you call a long arm. It's a honking big bed with a sewing machine on it basically. And the idea is that my wife can just walk in and say, you know, Alexa, turn on the sewing room light or whatever device she wants, and it'll just go on. She wouldn't have to go find extra switches because these beams weren't in when we moved in. And basically there's just an extension cord runs along and down the side. So what I'm doing is I've built a box that will go in the bottom of this under here. That's going to have 4 Martin Jerry switches on it, which are Wi-Fi. They're ESP8266 based smart switches, and I'm going to reprogram them to be able to use my home automation system, but they'll still have the manual push buttons on them. And then the wires will just run up and around to each of the lights and things to be able to turn them on and off. Anyway, that's basically what I'm going to be trying to do, and what I need to be able to do that is a USB to serial adapter that outputs at 3.3 volt level. And one of the easiest ones to use is one based on either an SIL 2104, which is what I have here, or a newer one, which is a 2102, CP2102N to be precise, which is the newer, faster one. And here's some examples of them here. You can get them from Amazon, which is where I've already got one of the earlier ones, so I don't need to buy one, but I probably will get one of these just to try them. So the ones I'm looking at is either this one, which is just a straight cable. It says it's 3.3 volt, but I think it's probably just 5 volts on here, so you need a little modification. Or this one, which is about the same price, slightly less actually, where you can use jumpers and you just use DuPont connectors or something to jump to your programming board. This one, though, has a USB-C type connector on it. Don't have these yet, so for this video where I'm going to show you how to program these boxes, I will be using this little adapter, which I got a long time ago, which is based on a CP3104. I'll let that focus on the board. There we go. So I've got the CP2104 in the middle. It's got a micro USB connector, and then just a 4 pin headers out off the side. You can see it's labeled there USB UART. On the bottom it's got the pin out, which is plus volts, receive, transmit, and then common, which is ground. And that's really all it is. It's just a USB to serial converter. It's got quite a few more capabilities. It's got all of the original RS-232, RTS, CTS, DTR, etc. connections on it as well, but they're not broken out to this edge connector. So that's what we're going to be using to program them. So here is the Martin Jerry, or one of them. The other 3 are already in here. And what you get in the kit, in the box, is just the switch, a couple of screws for mounting it. It has a faceplate if you're putting it into a standard single gang outlet. And the switch itself, let's get rid of the box there. So this is the switch. There's no external connections except for the mains, live, neutral, ground, and then the load connection, which goes out to your light, and then it would return back to the neutral wire, which is in this case in North America is the white wire. The black wire is live. So we have to be able to program this. Now Tasmota for a while was able to directly program these by using over the air, but they've been modified. The Tuya, which is the operating system in here, originally, for like the way this is, it's got Tuya OS in it right now, had blocked the, I say upgrade, they would say side grade to the Tasmota firmware. But if you open them up, it's very, very easy to be able to reprogram them. If I do this right now with this one, let's just open it up. It's very easy to get in. You just need a very fine blade, and if you just gently push this down away from the back, so you see a little gap forming, you can get in there and just pop it out. Okay, on that side. Do the same on the other side. You can see there's little catches here that are used to bind it up. Let's just move those around and get that little plate that hooks over here. Just need to unhook it. And here we go. Now, you can see on here, let me zoom back in again, that we have a row of connections here. Now, these are actually going through to various parts on the board, and you've got a cable running to the backer board, which has got the relay on, the power supply, etc. So everything that we're interested in for reprogramming is over here. So I'm just going to unplug this from here just to get it out of the way. And what I've done is I've looked at the other side of the board and figured out the pinouts connecting to the Tuya MCU. Perhaps I'll open it and let you have a look. First of all, just to let you see, just 4 screws. Now, to program this, you don't actually need to take these screws off. I'm just going to show you the other side. Okay, so what we have here is the Tuya MCU. It actually says model TYWE3S, I think that is. I'll put it on the screen. Anyway, this is the Tuya module. Basically, it's an ESP8266 with a memory EEPROM inside. All the pins are brought out here. You can get the pinouts very easily off the internet. I'll put a quick inline picture up of what the pins are on this side. But all of the pins we're interested in are actually brought out to this connector, and I'm sure they probably in factory use this connector for flashing it just before they're assembled. So let me just quickly put this back together. And it used to be that you used to have to download a whole bunch of different things or compile it using an Arduino IDE, because the Tasmota software is fully Arduino IDE compatible to be able to compile it, or using Visual Studio Code and Platform IO, and there are other methods you could use too. Or you can just get the bin files directly from the Tasmota GitHub repository, which is the easiest way to do it. And the way I'm going to show you is pretty much even easier than that. No software needed to be loaded onto your PC or anything. I'm just going to solder 4 connections from here. I've got, well, there's 4 to be soldered. I've got plus 3.3 volts, ground, and transmit and receive. I'm just going to solder these onto the pins on here, and then I'll show you how to program it. I'll be right back once I've soldered it on. Okay, you can see here I've wired up the connections. We've got the plus 3.3 volts, ground, and then the yellow one is connected to the transmit, which goes through here to the green goes to transmit, yep. And then the orange one is connected to receive, which is the transmit on this end. And what they are is they've got to be crossover. So what that means is that you've got your programmer, the 2104 chip that's on this little board. So it's USB here, and then it's the ESP board over here, in this case the Martin Jerry switch, and you have TX from this side, and then it crosses over to RX on this side, and then you have TX on this side, and it needs to cross over to RX on this side. Okay, and then you have plus 3.3 volts, you have a ground connection, and then the last one we have is a connection that we use like a switch that goes to GPIO 0. And if you ground this when you power it up, it puts it in the ESP8266 in programming mode, which is what we want. And you have to do that when you first power it up. So that's what this extra white wire is on here. It's just connected to ground on this little adapter for my USB serial adapter here. And all I need to do is hold it onto that third pin there, and I can just press reset. These particular Martin Jerrys have a reset button right here, separate to the on-off button. So if I reset it while I have that connected on the ground, then it will go into programming mode. Now that we're all connected up, we need to power this up, which it is now, and then I'm going to hold this white wire to ground GPIO 0. So I'm just going to push that on there and hold it. And I'm going to hit the reset button on the front, which is a little sub button. Try it this way so it's easier. So there's GPIO 0. I'll reset it. Okay, so that's done. I kept it pressed for a few seconds, probably not necessary. Now you can let go of this now. It doesn't need to remain connected to be in programming mode. You won't see anything on the front of it. But if I go to a website, okay, so switch over the screen capture. With this website, tasmota.github.io/install, I'll put the link in the description. You get this page and you pick the bin file that you want, in which case we just want the basic bin file, and you just hit connect. It will ask you what COM port you want to connect to. So here, the only one, which is a CP2104, which is what I have on this, is on COM4. If you're not sure what COM port you need to use, you can go to Control Panel, Device Manager. You can go straight to Device Manager. And you can have a look at the COM port. So you need to look for port COM and LPT. Now, I've only got one in here, but if I actually unplug that, you'll see it disappear. Okay, so there's no COM ports at all there now. So what you want to do is pay attention to that when you plug in. Okay, you'll see it come back. There it is. And that's the one we want. In this case, it's COM4. So if you've got more than one, you better verify it doing that. So here we're going to connect. Let's do it again. And we'll pick COM4 and we'll say connect. And it should start talking to the board. And if it has, it will ask me to install the latest release of Tasmota, English version, confirming what I want. You can also bring up logs and console. So if I bring that up now, we'll do this again in a moment. You can see there's not really much going on. If I hit reset on this board, right, it's put a whole bunch of things up there from the existing Tuya software. A whole bunch of other information that right now we don't particularly care about, but it does show you that you are connected. So I need to do another reboot and set it back into programming mode. And we want to install the release of Tasmota. We also, because it's brand new, we're going to completely erase the device. If we were upgrading from one version of Tasmota to another, you would probably not erase it and keep the data, the configuration in it. Say next. It's going to tell us, confirm we want to install the release version of Tasmota English. It should be 11 as the time of recording. And it's going to erase all the data on the device. So we'll say install, and it will start the install. Now, I haven't loaded any drivers. I have not set up any programming environment or anything. This is 100% using the web browser. In this case, I'm using Chrome, but it should work with others. Nice, easy, very simple. The hardest thing you have to do is some very, very basic soldering to put those onto the board. We're up to 86, 90%. Almost done. Okay, it's wrapping up. and complete. Perfect. How easy is that? So we'll just say OK. Now if we go to logs and consoles now, and I hit a reset on the board, now we're getting the verification that it's running Tasmota version 11. Wi-Fi manager set to active for 3 minutes. So this currently is looking for a Wi-Fi connection on 192.168.4.1 so that we can program it in the basics of the Wi-Fi connection. So that's telling us right here, there's the address we need to go to. So there it is. It's just popped up on the screen. This is connected to the Wi-Fi of it. So if I do that, I'm going to lose any other network connectivity, but that's fine. So I'll connect to there. Just give it a second to connect. Hopefully this will work fine. The other option is just to use your cell phone to do the basic setup. Not sure why it did that, but that's fine. That should have connected. Let's just verify. Yep, we connected. So in here, if I go to 192.168.4.1, and there it is. So we're connected to it. Now I want to tell it my Wi-Fi parameters. So I'm going to tell it I want to use Oaks Clan Home, which is my home network. I'll put in my password like that and hit save. And it should now reboot, connect to the Wi-Fi network, and it should tell me what it's connecting to. So I won't bother saving that. So it's got a 1.195 is its new address. This should now reconnect me to my default network and direct me to there. So there we go. So now this is programmed with the Tasmota software and it's connected to my network. You'll see that if I press the button, it still doesn't do anything, and no light. There should be a light here coming on and off because it's a basic configuration, but it does not know what I am connected to. So in here, I have to tell it. Now, there's another thing that there's available for when you're using things like these Martin Jerry switches is you can get templates. So let me just go and do a quick search. MJ-S01 template Tasmota. There's a standard one from this site, templates.blackadder.com. It's a very big repository of templates. There's also one from DigiBlur, which has a couple of extra features that it's, well, at least one that's important that they've added. So I'll open that one as well to show you the difference. So we'll do the standard one from Tasmota first. Here is the template right here. Now, there are 14 pins that you can basically play with. Here's them listed up here. And you can program each pin to be different types of functionality. So what this is doing is programming this to be LED 1 inverted, LED 2 inverted, that's on GPIO 4 and 5 of the ESP8266. And then you've got the relay on GPIO 12 and the button, which is this big button. Right here, that's the button. The reset thing is that little thing under there, is on GPIO 13. That's great. So we can take this, we'll just copy it, and we'll go back to the Tasmota page, and you just go into configuration, other, and up here there's a template. You can just overwrite, paste in the new one with that configuration, activate it. I'm going to call this MJ-S04 because I've done 3 other ones. I don't want to confuse it. This is just a device name. MJ-S4. I'm not going to enable Belgin Wemo right now. If you wanted it to work with Amazon and Google and things, you would turn this on. Right now, I just want it to work and send information to my MQTT server for the home automation. Anyway, I'm just going to show you getting it set up and the difference. So we've put in the template up the top, just giving it a friendly name. Now I just hit save. And what you're going to see here on the home page when it comes back in a minute, once it's rebooted, is you'll actually see an on-off button. And now I can toggle the status on and off. Now you can't hear the relay ticking because the relay is in the other box. All right, so on here, Alexa, turn off lab lead main. Right, just so you can see the light. It's now got a blue light on. It goes off and on, but there's no clicking of a relay because the relay is in this box and I haven't plugged it into that yet. Okay, so with that standard template programmed in from the Tasmota website, you can see here that when it's on, it's showing up with a blue, and when it goes off, it's just off, and you can't really tell whether it's powered up or not. Now, what DigiBlur has done is he's created another template which will invert the LEDs, so you can have red for on and off for off. So I could put this in here, copied from their website. So I go configuration, I go to other, I plug in this one and save. Now what we should have when I turn it back on is a red light. And there we go. All right, so it's red and off now. That's the difference between those two templates. And all it's done is inverted one of the LEDs. Switch their places, which is relatively easy to do. Now, the next thing we want to do, though, is I want to have it red and blue. And to do that, you can apply what they call a rule. So again, on DigiBlur's website, a little bit further down, it's got exactly the instructions. So we copy these two statements here. Just copy them off the website. We go to the console, and we don't have to go into what rules are or anything like that. We just paste it in as it is. So here we go. Basically what it says is if LED power 1, whatever this is, then LED power 2 is the opposite. And it flips it back as well. So we press enter for that. That's in. Now we also have to tell it to turn on the rule, which is basically saying rule 1 space 1. That just enables it. And now we have the rules turned on. Now if you notice already, the light is now blue, whereas it was off before. So now when I press this, it goes red, goes blue, which means it's on all the time when there's power on. And you can see if I go to the screen that it actually tells us here, if I press the power button on the front of the unit, you can see it's executing those statements. I'm not going to go into how Tasmota works. There's plenty of information on some of my other YouTube channels, YouTube videos. You need to connect it to a home automation system. I use MQTT and home automation HAS, home automation service. You can download it for free. It runs on a Raspberry Pi. It can also run on a PC and other things. And that's what I use. Now, if I want to enable this to also work with Amazon and Google and stuff like that, then I can go into the configuration. Sorry, not template, configuration other. And I can turn on the Belkin Wemo emulation as a single device. Now this is a switch. So now I'm going to actually change this to be the name of what it's supposed to be, which is a cutting light, sewing light, quilting light. Handy Quilter is supposed to be the name. And I've turned on Belkin Wemo, which means that Alexa should now be able to find it. Saying that quietly. So I can turn it on and off. You should be able to see, if I go back to Zoom screen. I'm clicking the web page for the device and it's turning it on and off. Now if I tell Alexa to find new devices, Alexa, discover new devices. So Alexa's acknowledged that it's now found it. Now if I just say, Alexa, turn off Handy Quilter. And there it is, it's gone off. Alexa, Turn on handy quilter. And there it is, turning it on. So that's how easy it is to reprogram this to use Tasmota, which means it's working locally. Now obviously if I'm using Alexa or Google, it's going out over the internet, but it now means I can easily integrate it into my home automation server, which is exactly what I want. It also means that once I plug this into the rest of the unit, aka this, my wife will be able to manually control things if she wants to by just reaching up, pushing the button, or she can talk to Alexa or Google and get it to do that, or she can push a button on her smartphone or tablet. Either way, it'll all be able to turn the lights on and off, and you can also do other fun things like have a motion sensor added somewhere and have things turn off automatically when there's no movement detected. But my purpose here was to show you how easy it is to program these Martin Jerry current model MJ-S01s just using nothing more than a web browser and a tiny bit of very simple soldering. I did nearly forget to just show you what to do once you're all finished with this. So just unplug it from the USB cable, unsolder your 4 wires. I'll just go do that now. So there we are, all unsoldered, back to normal. So just plug it back in the box. It'll only go one way. And put the lid back on. It just clips into place. When you clip it back together, don't forget to push the ground lead underneath that end clip before you push it back together. And that is it. Why don't I just go get a quick connect and show you it all working, running off the mains. Okay, so I've now got this plugged into the mains using the screw-its, which are perfectly fine in Canada. These are not going to be driving heavy loads or anything like that. Now, if I talk to Alexa, you should hear the relays clicking this time as well. Alexa, turn off handy quilter. There, it's off. Alexa, turn on handy quilter. And there it's on. So that's all nice and good. I obviously haven't got a load connected to it or anything. I can also control it from pushing the button. I can also connect to my web page for that device. And that works perfectly well. And I should be able to see it now in my home automation server as well. Let me just see if I can bring that up. Okay, here's my home automation server. There's a few devices in here. You may not have found it yet. Oh, it won't because I haven't told it where it needs to connect to, have I? So in MQTT, I need to tell it my host name, port number, username, and password. If that's working, then I should be able to go into the console. Yeah, so it's working now. It's connected to the MQTT server, which would then in turn forward information onto the home automation server. So you can see in the logs here it's working. So if I go back here now. Okay, I'd forgotten one setting for Home Assistant, which is to also do a set option 19 space 1. I'll put a few of these in the description so you can just copy and paste them when I'm done posting it. But now if I go back, I just did here, you can see set option 19, but the 1. And it's enabled the MQTT discovery. With set option 19 space 0 disables it. And so now, theoretically, when I go back over here, I go to configuration and devices, I should see, yep, it's gone up from 20 to 21 devices, and now I should see the handy quilter. There it is. Okay, so I can look at it in here and change settings and everything else. Now, if I look at the overview first, it's going to appear in a area of its own, probably. Yeah, we're here. So it's seen a switch, and it's a handy quilter. And I can turn it on and off from here. Okay. I can also tell it that it's now in the sewing room. Now, I can leave this icon. I can change the icon to whatever I like here. It's a whole list of them. I'll leave that alone for the moment. The name thing is I want to go to Advanced and set it to be in the sewing room. And I just update that in Home Assistant. If I go down to the sewing room, now we have Handy Quilter. I can turn it on and off. You can hear it. So, perfect. All right, that's the end of this video. If you liked it, give it a thumbs up. If you didn't, well then don't. I will be continuing with a video on how I made this box. This box. And how I've wired it up and everything else. So that'll be a little bit of like Fusion 360 and stuff like that. Very simple to do. I will share the designs of this on GitHub or on Thingiverse anyway. The main thing was to show you how to program one of these, which is now done. Lovely. My wife will be happy. Anyway, I will see you in the next video. Bye for now.